Hello fellas, welcome back. This should be a short video. It's on piecewise functions and the difference quotient. Um, and I know that you guys have been doing a lot of work, so let's get right down to it here. A piecewise function, again, these can be intimidating for students, so I want to make sure that you guys just watch this video carefully, and I think you'll be fine. But a piecewise function is defined by two or more equations over a specific domain. Basically what it looks like is this. And I have two parts to this function. This part here I use when x is less than 0. And this bottom part here I use when x is greater than 0. Okay, that's that simple. This is a piecewise function. It has two different definitions depending upon where I am in the domain. And so let's look at a couple different questions here. What is f of negative 4? Well, I look here. How do I do this? F of negative 4. So negative 4 falls into this part right here. And so all that means is I use this part of the function. And if I plug in negative 4 to this part of the function, I should get negative 2. Okay? Do another one. F of 4, now if I'm looking at 4, where am I on the domain? I am right here. Okay? So for this particular part, I want to use the x squared. So if I do that, I should get 16. Let's do something else here. Let's 0. Now again, the boundary points you have to be a little bit careful. Here, if I'm looking at 0, this is the function, this part right here is the one I want to use when I'm at 0 because it's greater than or equal to 0. If I do that, you should see that I get 0. The other thing that you want to be able to do is to graph a piecewise function. And graphing a piecewise function is just like graphing each one of these, but cutting it off depending upon the domain. Let's look at a little graph here. So if x was less than 2, I just wanted the straight line with equation x plus 2, and that's what I did. Note, x is less than 2, I just use a straight line defined by x plus 2. When x was greater than 0, when I'm greater than 0, I want a parabola, x squared. And I just cut it off. I start at 0, and then I use that domain part of it right there. Okay, so it's just like graphing that we normally did, but we just cut off the segments that we don't need. Let's try another example there. Here's a piecewise function defined by three different aspects of it. Okay, there's three different parts to this one here. So let's just let's look at evaluating some things. F of 3. Well, if I'm looking at 3, I'm following into this part right there. Okay, so I want to use this part of the function. If I go negative, if I go 3 squared, I get 9, and I get negative that. I get 5, which is not right. I'm not sure. That should be 3. Okay. If I look at the next one, f of 0, I'm in this interval right there. So for this one, I'm going to use that one right there. If I plug in 0, I'm going to get 1. Okay. Hopefully this is making sense. Negative 2. Oh, again, look at, I got to figure out, but this is the less than or equal, greater than or equal to negative 2. So for this one, I'm going to again use this part right there. Okay, and I should get negative 3. F of negative 3. Okay, again, find out what part of the domain I'm on. That one, I'm way up to the top one. And if I do that one right there, whoop, I get negative 4. And let's do another one. F of 2. Again, this is a boundary point. That boundary point is telling me that I'm going to use that one right there. And I get 8. Okay? Hopefully that makes sense. Now, if I wanted to graph this, I'm going to have three different segments. Here is the line, straight line, this part of the function when I'm less than negative 2. And then when I'm between 2, negative 2 and 2, I'm going to graph this part of the function right there. And then when I'm greater than 2, I'm going to have my downward parabola. See how I cut off only the parts that I want in between the different segments? Okay? Hopefully that makes sense. I'll give you a couple practice problems at the end of this section to deal with piecewise functions. Don't make them more difficult than they are. The other thing I want to talk about, and this is basically because you're going to see this a lot in calculus, we might as well get used to using it. This right here is called the difference quotient. Okay? This is actually going to come into play with derivatives, which we'll see towards the end of this class. So let's get used to playing around with this a little bit. And if I gave you a function f of x equals x squared plus h, let's look at finding the difference quotient. Okay? And again, whatever I have in parentheses right there, when I have that x plus h, I'm just going to plug it in wherever I see an x in the equation. Okay? So what that's going to actually look like, I see an x, I plug in x plus h, and I square it. I still have my plus 1. And then it says subtract from that f of x, just a regular function, which is x squared plus 1 over h. Okay? Hopefully that makes sense. But now the challenge is to simplify it. Again, wherever I saw an x, I plugged in the x plus h for this term. If I expand that term out, I get x squared plus 2xh plus h squared plus 1. That's this first part. This part right there is f of x plus h. Okay? And then I wanted to distribute the negative through to both sides. So that's why I got negative x squared minus 1. Let's do some simplifying here. The x squareds cancel, the 1's go away. And if I simplify and I divide by, all I'm left with are those two terms after I cross things out right there. And if I divide an h out of both, I get 2x plus h. This is actually going to tell us about the derivative. I know that doesn't mean anything to you now, but understand that derivatives are critical when we start talking about calculus. Let's do one more example of those. Here's a different function. Find the difference quotient f of 5 plus h minus f of 5 over h. Again, we're going to do the same thing. And so for this part right here, wherever I see an x, right there and right there, I'm going to plug in 5 plus h. And I do that. I also note that f of 5, if I plug in f of 5, I get 0. So this term right there is f of 5. Okay? Makes it a little bit easier. So if I do this and I distribute through, I get 25 plus 5h minus, now I have to square that whole term, which is right there. All right, all divided by h. Again, we're just going to do some simplifying. And I'll note that the 25s are going to cancel out. And then again, I got an h. I can divide each of these terms by h. I get 5 minus 10 minus h, which gives me negative 5 plus h. And again, h can't be 0 here. Let me write that h. Whoops. Cannot be 0. All right. So that is the difference quotient. A little bit different because this time it has a 5 and not an x in it. But not a big deal. It's still a difference quotient. All right. Just some practice here, fellas. I'm going to have you practice on a couple problems. These ones right here have to do with piecewise functions. This is another domain problem, and this is a difference quotient. All right. Questions, again, you need to email me. Basically, this video was a pretty quick one. Talked about how to analyze piecewise functions, how to graph them, how to evaluate them, and then we looked at the difference quotient, okay, and how we had to simplify and get used to start using that for things in calculus that we'll see down the line. Okay, hope you guys are enjoying the class. Hope you guys are starting to understand it. And again, make sure that you email me if you have any questions. Have a nice day.